Hey, Anne, do you have any plans on April 28th or April 29th?
I actually do, Ruby. I am going to be a speaker, which is like one of my favorite things to do.
Oh my goodness, me too. I'm going to be at the Seattle Reproductive Symposium.
That is where all the hip healthcare providers are going to be this April. So if you are one of our many listeners that is a provider, we want to share with you the opportunity to get in on that early bird pricing. Up through March 27th, you can sign up at a discounted rate, and it is such a great thing to give to the community.
That's right, and it's up to 11.5 AMA Category 1 credits, and there will be 5 of our previous guests from our podcast speaking. So Dr. Nicole Barker, Dr. Sarah De La Torre, Judy Simon, Laura Hayden, Kristen Chambliss, among many, many other wonderful guests.
And we have some hands-on workshops. So the Thursday before, there's an ovulation planning workshop, and that Saturday afternoon, there's a workshop all about doing IUIs or intrauterine insemination. So if you are a healthcare provider either in the Seattle area or interested in coming to the Seattle area in April to meet us, find the full agenda, register. Everything's online at seattlereproductivesymposium.com, and we are accredited and hosted by Seattle Reproductive Medicine.
Welcome to The Whole Pineapple. I'm Ruby Boris.
And I'm Ann Judge. The Whole Pineapple is a podcast about wellness focused around fertility. And on these weekly mini episodes, we bring you bite-sized ideas for you to snack on.
Like breathing exercises, book reviews. Maybe we'll review some scientific research, or we'll share some wellness and fertility stories from our listeners.
So if you're looking for a tip or a trick related to your fertility and well-being, then you've come to the right place.
Let's dig in.
Welcome to the Whole Pineapple Snack this weekend. This is a little bit of a bonus snack. It's just going to be me and Ruby because hopefully you listened to our main episode on epigenetics, and we had so many interesting things to talk about with Dr. Thornburg, and we ran out of time to talk about one of my favorite things, which is using history, especially the data that we have from famines that we mentioned briefly in our main episode, and how that teaches us things about epigenetics even before all the recent advances we have in actually being able to study the genetics. So today we're going to share some of our famous favorite famines. Favorite famines. I know, it's hard to say, isn't it?
If we can have a favorite famine, I guess. Right?
Yeah, it's a little weird. I know, I do have a favorite now, actually, after reading, just in terms of, but
okay.
Do you have a favorite famine?
I do, after I did some research on this, just because I do like history, so I did get into it a little bit, but just as a reminder, what epigenetics is, it's the interaction between genetic factors and the environment and how that shapes the development of the individual and the health of the individual. So basically the things that we're exposed to are our habits or behaviors, exposures, environment, all that stuff can turn genes on and off, altering how they are expressed.
And there's a really good article I found. It's about twin studies. I'll talk about it a little more later. It was from The Atlantic in 2018 by Erika Hayasaki, but she has a really good example in there. She's talking about epigenetics, the term, epi kind of means on top of or above. So it's kind of like on top of your genes. And she uses the analogy to consider genes as being instruments in the symphony of life, but they don't play themselves. They need musicians. And that's what epigenetics would be. It'd be the musicians that are helping to either express or silence that performance of the genes. And so just like if we were talking about an orchestra and whether or not the player is going to play the instrument the right way, exercise, sleep, stress, trauma, diet, all those things are going to influence how someone plays their instrument, just like how epigenetics influences genes.
That's really cool.
I know. I was like, I got to steal that, but I got to give her credit because that's a really good analogy.
Another fun example that I found when I was doing research was something on honeybees. So I found this really fascinating. So I found this, it was an article, Australian Academy for Science, and it's called What It Takes to Make a Queen Bee. And this article was adapted from the Academy website following expert Professor Boris Bayer. So Professor Boris Bayer, this is where that came from, which sounds very interesting. I just really like that person's name. It's kind of a cool name. Anyway, so with honeybees, both a worker bee and a queen bee all start off the same. For the first 3 days, they are fed with something called royal jelly, which is a gel-like substance that's produced by the head glands of the nurse bees.
And you certainly, if you're a fertility patient, you probably heard about people taking royal jelly supplements. So
I forgot about that.
Oh, yeah. I'm like, oh, we're going to talk about the bees, but that's not the point of today's episode.
So this royal jelly, it's about 2/3 water, 1/8 proteins, about 11% simple sugars, and a small quantities of vitamin C and trace minerals, enzymes, and things. It's not exactly sure what it's made up of, but we do know that it has compounds in it that influence gene expression. So after those 3 days, those ones that are destined to be worker bees receive no more of the royal jelly, and they are switched to something called bee bread, which I just love,
Nice.
which is a mixture of pollen, nectar, and honey. The queen bees are only fed royal jelly for the rest of their lives, basically.
Of course.
Yes.
They are royal.
Because they have their crowns on. And so worker bees end up being smaller, have different anatomy and behaviors. They die after stinging, and they have relatively short lives, which is about 5 to 7 weeks. And then queen bees can live up to 4 to 5 years. And if you've ever seen a queen bee, they look remarkably different to the worker bees. But they're not quite sure if it's just the strict royal jelly that causes the queen bees, or is it something in the bee bread, like in the pollen, they're thinking that actually convert them to worker bees instead. So there's something obviously in the diet that makes these two different.
That's probably the reason that you're interested in learning about the famine studies, because it's all about nutrition and how, like, and the lack thereof, or for the bees, the best jelly versus bread is going to influence the expression of those genes.
Yeah, I find it fascinating. And let's go into the famines, because the one that we mentioned in the episode was the Dutch famine, which is very interesting because it was a relatively short. It was unique in that we had like this kind of natural experiment that happened, for lack of a better term. I know these are all human beings that went through something awful, but we did learn a lot from this period of time.
Many articles about it, but I like this one just because it's kind of a succinct summary. This is from an article in Nature that's talking about tales of adversity in epigenetics. And again, they called it at the time the Hunger Winter, but spelled in kind of the Dutch way. And basically, near the end of the Second World War, you had food supplies in the northern and western regions of Holland were really limited because the Germans were halting transport of goods. And there were actually like people in the city that, as part of trying to stop the Nazi advance, kind of shut down railway lines. And that's great, except that means they also were shutting down their supply lines. And then there was a harsh winter and the canals froze. So suddenly you really had no way of getting food in or out of the city. And so rations in the city dropped to being 500 calories per day or less. So again, everyone's suddenly having less than a quarter of the recommended intake. And this happened, late 1944. And then, as Ruby said, in May 1945, the city's liberated. So you have this real kind of short, very sudden, and then rebound time. And that allowed for a lot of natural data to look at. Now, as Ruby said, this is awful. During that time, and they say about 18,000 people starved to death. But what they do when they're looking at data is you're able to compare children that were born either just before or after the famine resolved with the children that were actually conceived or at some part of the pregnancy during this time. And that's where they're able to see these kind of really interesting differences. And even now, like there's just an article a couple years ago in the New York Times saying that like 70 years later, you still see these changes in other generations because of the famine. So that's the reason scientists, they're never going to be able to like put people in a situation like that. But when it happens historically, it gives you this natural experiment to see like, gosh, what does this do and how does that persist in different generations?
Yeah, that New York Times article is the one that I was looking at too. And what's really unique is before the famine, pretty typical society, there wasn't any major hunger issues besides the typical before that time. So it was such an abrupt change. And then following liberation, it went back to quote unquote normal. So it was this brief period of time. It's very interesting that they basically had a set experimental time. The changes were most notable in pregnant women and obviously the offspring who were in utero during this time. For one, and in middle-aged people that were in utero at the time of the famine actually ended up being heavier on average and had higher triglycerides and LDL cholesterol, higher rates of obesity, diabetes, and schizophrenia. Those in utero during the famine died at higher rates than people born before or after. So it's a 10% increase in mortality after 68 years, about that 68-year birthday for people.
And it's interesting because when we go through other famine data, you see kind of these similar patterns, which is why people are interested in it. But it's still not 100% sure that like this is what caused it in terms of epigenetics. I found a good chapter in a textbook about historical trauma and epigenetics, and they pull out that really there's still like 4 hypotheses to try and explain these consequences after famine. Like one is that it's epigenetic changes, but also, we're talking about people. So people's behaviors are going to change afterwards too. So there's this thought that there are probably persisting cultural food-related changes where families that have gone through something like this are probably going to always be eaten in a slightly different manner. Maybe there's more overindulging because once you've not had food, you're going to always look at differently.
You better clean your plate. There's starving people in the world kind of thing.
Exactly. Or there's this kind of what they call the thrifty gene hypothesis. So saying, again, maybe the people that survive these famines have a genetic code where they're going to be more likely to hold on to these excess calories. Same thing for what they call a thrifty phenotype, which is that, again, it's more that the actual like pancreas itself is maybe going to react differently. And that's why you get that risk of type 2 diabetes. So it's not like we know 100% that this is epigenetics is the only thing that caused it, but we see that this is a real effect and we see it in different historical data.
Yeah, but it's passed through generations because as Dr. Thornburg was mentioning, people that were in their mother's womb at the time of the famine, the female ones, their eggs were exposed to the famine as well. So we're talking about future generations, even past the people that are actually in the famine at the time.
They're doing actual research with this. They're getting DNA from the people that are still alive, and they find changes in insulin-like growth factor 2 expression. Like they find all these sort of fascinating kind of chemical differences. It's just you still don't know exactly, what's cause and effect, but it provides this resource because it is still in our recent historical memory as opposed to some of the famine that I want to talk about next.
That's the next. I bet it's the
famine.
Is it yours too? That was my favorite as well. But one thing that I found really fascinating, those female fetuses that were exposed during the famine grew up to have more children overall and gave birth to more twins, were less likely to be childless and more likely to have children at a younger age. And it just makes you think, like, is there something that happened in their genetic code that says we need to reproduce more because we don't know if our children are going to be able to survive? It's a very morbid thought, but it's interesting nonetheless.
All right, so we're going to dial back in time. Are you going to Ireland?
I'm going to Ireland.
Yeah.
The Great Hunger.
I guess it's my favorite because I feel bad like having some Irish ancestry and being married to someone who's very Irish. Like I didn't really understand how bad the Irish potato famine was. It's something that sometimes you hear just like joked about in popular culture, and you're like, oh my gosh, this was just like an insane amount of devastation and death.
My ancestors on my father's side immigrated from Ireland. I don't know the exact dates off the top of my head, so I don't know if it was a result of this, but I do know that I have a large portion of my heritage that comes from Ireland. So this was earlier than the Dutch potato famine. This was in 1845 to 1852.
So almost 100 years earlier. It's kind of interesting. It's like you have like 100 years between.
And so we don't know as much because we weren't thinking about these things at the time. And it also lasted for a longer period of time. Lots of things were happening at the time politically and with the crops and things at the same time. So it's harder to narrow down cause and effect here.
But it's also fascinating. If anybody else is watching The Last of Us, it's the idea of like how toxic fungi, it's like it all goes back to mold, that you have mold destroying the potato crop, and you wouldn't necessarily think that this would cause as much as it did. But do you want to summarize the potato famine?
It unfortunately killed like 1 million Irish citizens and forced another 2 million to immigrate. So that's 20% of their population at the time, which is incredible. That's a huge amount of people. And it's affected the lives and health of nearly every generation that came afterwards. So the environmental shock during the pregnancies for those that were pregnant, the one thing that they found primarily with this was the mental health aspect. So mental health particularly was sensitive to the epigenetic changes that happened. And the mortality in cardiovascular disease was also different in people that followed this famine. But the mental health outcomes are interesting. It's hard to really say if this is strictly epigenetics, if there's actually change in gene expression, or if it was like, hey, we just went through something very traumatic kind of thing. And so that does change your mental health. this does bring up things that we talk about now and hopefully are coming a little bit more to the forefront in people's minds about generational trauma, because it's a real thing. And it's that thought that potentially, quote unquote, memories can be passed down through generations.
Yeah, most of the data that I found on this was talking about the increase in schizophrenia. And it's still like a little bit of an open question because, again, it's hard. You're looking at historical records from like 100 years ago. But you also have this kind of pretty recorded Irish asylum system where you can kind of see the admit rates. And they found this increase of schizophrenia admission rates with an increase of 85.7% between 1860 and 1875, which is basically that age window of time, because schizophrenia tends to present in the sort of later teens, early adulthood. Like that's when you would have this cohort of children who had been in utero during this really traumatic event, suddenly hitting this time that is when, if you happen to have whatever that genetic predisposition is for schizophrenia, this is when usually symptoms would be presenting. And so again, we're never going to have the exact answer because it's not like the Dutch famine where you can still find some survivors and check blood samples, but you have this really historical event and a change in historical data, and it does line up with the things that they see in other famines that have been studied where you often see this increase in schizophrenia.
One of the articles I read on this, if you want to learn more about it, it was really well done, was on the website called Longevity. It's the Irish Potato Famine and Epigenetics, and it was written by Kayla Bloom. And it's a really good just rundown of what was happening during the time and specifically with the mental health stuff that was happening. So potato blight was a major problem in addition to other things.
Well, and also I think it's important to mention because we think about famines as often a result of, really low resource settings. And so although the potato famine isn't the worst famine in history, this occurs when Ireland was still part of the UK, which at the time was the wealthiest country in the world. So you had this situation where you would think there should have been the resources to help. And the way that it played out is kind of what really led to this movement of independence and, so much continued.
It had waves, echoes throughout for history. It changed the history of the world.
And I hadn't realized that's part of the reason there is such a strong Irish American history in the US is that so many people, again, a couple million people immigrated during that time because they had to eat somewhere.
One other thing that I noticed because of all the immigration and other things that were happening with England and Ireland at the time, the Gaelic language actually showed a sharp decline, specifically linked to this time, which is so sad because I really actually love the Gaelic language. It's very cool. It's very difficult, I hear, but it's very cool.
I think I only know about it from Daniel McKenna on Peloton saying a few phrases. But it is, I haven't been to Ireland. I want to go to Ireland. And one last famine thing, just when we're talking about how that's not the worst famine. So in terms of pure numbers, we also, just a little bit past the Dutch famine, you have the Chinese famine, which is basically from 1958 to 1961, during a combination of, the Great Leap Forward and Mao Zedong. You had basically, in that case, tens of millions of people that died due to hunger. And again, you see this similar rate. You see increased rates of schizophrenia. And it's amazing to think that there still are things happening. There is a famine in the 1970s in Nigeria that we also see propensity for obesity in survivors. So, you'd hope that as a world with the resources we have now, there wouldn't still be the situations, but they still are there.
And the schizophrenia thing is very interesting because you're like, I wonder if this is an epigenetic adaptation, what is it about that's how it, it evolved to that kind of adaptation. It's very interesting. We don't know that yet, but it is fascinating.
Well, that's what kind of leads into sort of the cool stuff about why we can look at twin studies too, because as good as a comparison group as it might be in a family to have children that were conceived after or before, it's still different people, right? You still have different genes. But when you look at identical twins, like we talked about in that main episode, these are people that really share that same genetic code. And so that article that I mentioned earlier that we'll link to, again, it's Erika Hayasaki in The Atlantic. It's called Identical Twins or Living Epigenetic Experiments. And this is back in 2018, and her clinic of twin studies was at that time had just finished studying kind of their just over 100th pair of identical twins. I'm sure they have even more now. And the article starts off with that example of two 39-year-old identical twin women where one ended up having a pretty aggressive breast cancer and the other did not. And they tested that neither one had the BRCA gene mutation, which can sometimes account for 5 to 10%. But again, they contain basically the same 20,000 genes. And yet, why did one of them develop breast cancer and the other not? Because they also grew up in very similar environments. That's your other thing with identical twins. Although there's obviously still going to be differences, you feel like, gosh, what is it epigenetically that is different enough to activate something in one person and not in the other?
Yeah. And then we've also seen it in twins that were separated at birth.
Yes, that is the next part.
I can't remember exactly where they are. I think they were in the Midwest, but they were only living like 14 miles away from each other. And they ended up
all the stuff. They married women of the same name. They named their dog the same thing. They both divorced the first wife and married a second wife of the same name.
I'm like, no, that is the weirdest thing, just fact.
I've got a weirder one, though, in that argument. This is the thing that really blew my mind. So again, if in that case, we're talking about twins that they were, raised in different environments. Here you have even the most perfect natural example. Basically, Dr. Siegel, who's kind of this article, what they're talking about at the twin studies, she then started doing exactly what you're saying, Ruby, studies on twins that were separated or switched at birth and, how are they different? And basically, she found this case. She has 9 or 10 cases now of switched at birth where you had 2 identical sets of twin brothers that were born in Colombia. So you had 2 sets of identical twins, both boys, and they got switched, just one from each pair. And so both families thought that they were raising fraternal twins because you had 2 sons, but obviously they looked pretty different.
Wow.
But then years later, one of the coworkers of one of the brothers went to a butcher shop on the far side of town and saw someone that looked exactly like their brother. And that's when they found out it was the identical twin of the brother. And so you found out that there had been this swap of 2 identical twin sets, and they raised, so you have this sort of natural comparison group on both sides. And they did cheek swabs, and they found all these interesting comparisons between them, but also that the differences were different. So basically, out of your 2 sets of pairs, you had one identical pair that epigenetically was still very, very similar, even though they'd been raised apart. But then out of the other pair, the epigenome of the brother that was raised in the city was really different from the one that was raised in the country. And so they were talking about it. Is it because of pollution or pesticides? What is this? But even in that situation, why did it impact that one twin, but not impact the other twin if you both have one city and one rural? So it's just fascinating. And one of their theories is that, again, we're talking about epigenetics for their environment after they're born. But as we talked about in the main episode, there's still that in utero environment. So maybe it was even before they were separated. One was getting more placental blood flow than the other, and maybe that's what triggered it. Or again, it could just be spontaneous variation even within that same genetic code. But it's boy, you think that you have just studying switched at birth is the weirdest thing, but to be able to actually study switched at birth where you have your 2 different sets gives you you couldn't even believe you could design a situation
Yeah,
like
it's
that.
so interesting. There's just so many factors that clearly play a role in how our genetics work that we're still in the beginning phases of understanding all of these things, but it's fascinating. But I would be remiss if I did not bring up a famous lifestyle medicine study. It's a very famous book called The China Study, written by T. Colin Campbell and his son, Thomas Campbell. It is a book based off of this very large study that looked at a lot of different things, just a ton of data. It was one of the largest comprehensive studies of human nutrition ever conducted. So over 6,500 adults collected over 20 years. So that's a lot of information. A lot of people have heard.
That's huge. When we're talking about famine studies, when you look at these articles, most of the time it's 60 people, data from 100. And that's great. But yeah, this is definitely an order of magnitude in terms of really having big numbers to crunch.
A lot of people have started hearing about this because this is one of the things that inspired President Bill Clinton, to go vegan. So it also inspired the plant-based nutrition certificate program at Cornell, which Dr. Barker and I both have completed. I have to say, it was very great, informational. You can see interviews with Dr. Campbell on the documentary Forks Over Knives, so it's relatively well known now, but they ended up with more than 8,000 statistically significant associations between lifestyle, diet, and disease. That's incredible. Don't worry, I'm not going to go through all 8,000 of that. Key findings, though, the biggest one is that animal protein promotes the growth of cancer. So the food you eat can impact how your body responds to carcinogens, basically, is one of the main principles of this. It also looked into heart disease, which has been looked at further after this study or at the same time as the study. So Caldwell Esselstyn Jr. is a physician researcher at the Cleveland Clinic, and he took his patients who were diagnosed with coronary artery disease and fed them a whole food plant-based diet without oil. The intervention stopped the progression of disease, but in 70% of them, they were found to have an improvement in the diameter or the opening of their clogged arteries. So it actually reversed heart disease, which is incredible. It's a very small sample size, but pretty incredible nonetheless. And then same thing with Dean Ornish. He also did something very similar that confirmed that heart disease could be reversed. So,
well, that's why we talk about the epigenetics, because it is, something that is still changeable.
Exactly.
That you can't change your genome, but you do have this ability to try and reverse damage from the past.
Exactly. And so this is a standing invitation for any of those individuals that I mentioned to come on the podcast, because they are like rock stars to me, and I might cry or go catatonic, or die. I don't know, but it would be totally worth it.
But it wouldn't be from clogged arteries.
No, it would not. It would just be starstruck. But highly, it's kind of a heavy book, very medicine and research heavy. But if you are interested in that kind of stuff, I highly recommend it. One more thing that is really incredible that I don't know if, Anne, you are a part of the Nurses Health Study.
I don't think I'm that old.
So there's been more than one. So there's NHS 1, okay. NHS 2, and I am part of NHS 3, which started in 2010.
Okay. Yeah, I don't think, as I say, I'm still reeling from the American Girl doll from the 90s. Being out now. So I just...
Oh, yeah. No. So the first Nurses Health Study started in 1976, and it had over 100, almost 122,000 nurse participants. So before that, we didn't have a lot of information about women because most studies were done on men.
Yeah, we're just inferior men, so it makes sense.
Why study our genes? So it was a series of prospective studies that examined epidemiology, long-term effects of nutrition, hormones, and the environment. So really incredible. Then 1989, the Nurses Health Study 2 was of younger people. The first one was of, I think the youngest ones were 43, but in the second iteration, it was 25 to 42. So younger nurses, 117,000 nurses for that one. 90% of them still participate to this day. And then in 2010, that's when they started their new one, which is also looking at shift work and chemical exposures and fertility. So we are actively gathering data right now for different things that impact our fertility, which is really interesting. So I have been participating since 2010. So
look at you, helping science in so many different ways.
That's right. I know. I wish I could see the data that they're working on, but that wouldn't be appropriate as a study participant. Do you have any last thoughts about generational trauma or anything like that before we sign off?
No, I think that's definitely its own thing, but it's good to at least mention because, we don't want people to think when we're talking about epigenetics and it's all about methylation. There is a larger, broader
Absolutely.
view too that we're thinking about. So, because again, we're talking about people. We're not just talking about things in a petri dish, and so it's very hard to separate everything out. But we hope this is a taste of the exciting field of epigenetics. We will link to our sources if you want to read more. And if you didn't listen to our full episode with Dr. Kent Thornburg, please go back and listen because it was a really great discussion. Thanks for joining us for this week's episode of the Whole Pineapple Podcast. We hope it was helpful.
If you know someone who could benefit from hearing the podcast, we hope you'll share it with them.
And don't forget to subscribe, rate, and review The Whole Pineapple on your favorite podcast app. Every rating and review makes us easier to find.
This podcast is sponsored by Seattle Reproductive Medicine and is produced by Audiotocracy Podcast Production. We'll see you next time. Have a delicious week.